anybody see a pattern here? I know more than Charles. I don't think Charles is the only one who sees the pattern. All right. Sorry, Charles. He's just helping me out because nobody else is participating. All right. The next row is 1, 6, 15, 20, 15, 6, 1. Okay. So let's just tell me some things that you noticed. It can be very obvious, or maybe it's something less obvious, about Pascal's triangle. So you see it forms a triangle, right? Okay, what are some things you notice about this triangle? How about, do you notice anything here on the triangle? What does each row begin and end with? A 1, okay. And this is called row 1. This is where my pen is row 2, row 3, row 4, row 5, row 6. Do you notice any correlation between the row number and anything you see in the row? So row 3 starts 1, 3. Row 4 starts 1, 4. Row 5 starts 1, 5. Row 6 is 1, 6. Well, how is row 7 going to start? Same way, 1, 7. How is row 7 going to end? 7, 1. How do we get those things in the middle, though? Okay, so you're seeing the 2. Okay, this starts with a 2, and then a 3, and a 4, and a 5, and a 6. How did we get these things in the middle? Like, how did I know that this was a 15?
Oh, I see.
If you go above it and take the 5 and the 10, you get a 15. Oh, and then a 10 and a 10 is 20, and a 10 and a 5 is 15. And a 5, you could even do it with that, right? Okay. So tell me what the next row is then. 1, 7. Tell me. 21. 35. 35. So I'm hoping something else that you see is that there is symmetry in each row. Do you know what I mean by that statement? Okay. If I were to draw a line down the middle, the numbers are symmetrical on either side. Okay, so then I need you to get your calculators out for me, please. Oh, while you're getting your calculators out, in this lesson, our book, the way that they write combinations, remember this from yesterday and Monday, NCR? Remember that it means n factorial over n minus r factorial, right? Okay, we wrote that down, correct, the other day? In our book, they have a shorthand notation, and it looks like a long parentheses, and the n is on the top and the r is on the bottom. So if you see that today, don't get confused. These two things mean the same thing. So if you saw this with a 7 and a 3, that just means 7C3. All right, so back to the calculators. Let's take a row. Logan, pick a row for me. Doesn't matter what row. Okay, thank you. With your calculators, or maybe you'll do it, I just want you to identify row 5 in here, and then what I would like you to do below it is, would you find 5C0 for me? And you might know what 5C0 is without using your calculator. I hope you do. Maybe not. What is 5C0? It is 1. Okay. I'm writing it this way so you are learning the little notation thing I told you. Okay. Then let's find 5C1. What is 5C1? 5. Okay. Can you tell me what 5C2 is? It's 10? Do me a favor, leave some space here. What's 5C5? Nope, actually do it, if you're not sure, do it on your calculator. What's 5C5? Yeah, 5C5 is 1. Five C4. Okay, so when you do 5C4 in your calculator, you get a 5. So now compare that to row 5 of Pascal's triangle, and what do you see? They're the same. So for instance, if I asked you to generate, I don't know, row 11 of Pascal's triangle, you don't have to write out all the other terms. What you could do is take 11C0, 11C1, 11C2, all the way up to 11C11. And we would know, we wouldn't really have to do all of that because we would know it would start 111, right? And end 11-1. Okay, so that's a second thing that I want to point out. Did you guys know that? No? Then the point of what we do today, there's like loads and loads of applications of Pascal's triangle. But the point of what we do today is I want you to notice something interesting happens when we start to expand binomials. So I'm going to do the first two the long way, and then after that you're going to just trust me, hopefully. I'll do more than the first two the first two real powers. What's anything to the 0 power? 1, right? Okay. I'm going to put that 1, I'm just going to kind of move it over here, okay? How about what's a plus b to the first power? A plus b. I am going to position that a plus b right kind of like I did with Pascal's triangle, and I'm going to point out to you what is the coefficient of a, even though I didn't write it down. 1. And what's the coefficient of b, even though I didn't write it down? 1. Okay. Back from our algebra days, we hopefully learned that a plus b squared does not mean a squared plus b squared. It really means a plus b times a plus b, correct? What is a plus b times a plus b? Good. So I'm going to then position that a squared plus 2ab plus b squared. I am going to again put a 1 here and a 1 here. Okay, so do you agree with me that a plus b to the third would be a plus b times a plus b times a plus b, correct? Didn't I already calculate a plus b squared? So wouldn't I just have to multiply that by a plus b? Okay, so I'm going to do that a second. So I'm going to take a plus b squared, right below here. That's a squared plus 2ab plus b squared. And then I'm going to multiply by a plus b, and I'm going to see what happens. Alright, so here we go. What's a squared times a? A cubed. What's a squared times b? Isn't that just a squared b? Okay. All right, on to the 2. What is 2ab times a? 2a squared b. And then 2ab times b is 2ab squared. Okay, finally, let's do the b squared. B squared times a is plus ab squared. And what's b squared times b? B cubed, correct? Okay. Now, let's add like terms together, and I'm going to place it in the same spot here, okay? Are there any other a cubes? Nope, so I have just 1 a cubed. Okay, do you see here how I have 1 a squared b plus 2 a squared b? So I have plus 3 a squared b. And here, do you see how I have a 2ab squared and another ab squared? So I also have plus 3ab squared. And then plus 1b cubed. Okay. Does anybody see it yet? I'm highlighting those because what do they correspond with? The triangle, okay? And so what we notice are there's some patterns here. And we can use this to expand binomials instead of having to do this multiplication out over and over and over and over. And so the first thing we notice is that aren't the coefficients that I see here matching up with the row of Pascal's triangle? Okay? Another thing, notice this is a cubed. It starts with an a cubed. Then what happens? Goes to a squared. Then it goes to a, and then it's really a to the 0. It's gone. Don't the b's go in reverse? So b cubed, b squared, b to the first, and so on. Okay, help me out, guys. Can you tell me, with no math except this, what is then a plus b to the 4th? Well, how would I figure out the coefficients? Where do I look? Let's look at row 4 of the triangle. And by the way, we learned we don't have to write out row 4. We could do 4C0 if you wanted to, if you didn't want to write Pascal's triangle every time. You could do 4C0, 4C1, and so on. All right, so I am going to write out row 4, and I'm going to leave some space. I'm going to write a 1, and then I'm going to write a 4, and then a 6, and then a 4, and then a 1. All right. Now let's talk about what the degree of a is. What would be the term here for a? A to the 4th. Now some people like to go ahead and then go to the back and put b to the 4th here. It doesn't really matter what order you do that in. Okay. Then the next term, it's a cubed, and then there would be a b, correct? Okay. Then at plus 6a squared, and then it would be b squared plus 4a b cubed plus 1b to the 4th. Okay. So, binomial expansion is not quick by any means, and it's not even that super quick with this, but it definitely saves us some time once we see those patterns. Does that make sense? Okay, let's do one more with a number. Let's do one more with a number, and then I'm going to tell you how you can find individual terms. Okay, so what I would like us to do is expand, I don't know why I wrote my P there, because it's 6 hours, it's been a long day. Expand x plus 2 to the 6th power. Okay. So the first thing I'm going to do is I'm going to go to row 6 of Pascal's triangle, or if you don't want to draw Pascal's triangle, you could generate it, right? Okay. 60, 0, 61. Tell me what row 6 says. 1.
6, 15, 20, 15, 16.
Okay. Now, I want to point out to you that this is not a letter, it's a number, and so I still am going to have to raise it to a power, but above we didn't know what b cubed is, but now we are going to figure it out, okay? So first I'm going to go to the x. This is going to be x to the 6th, x to the 5th. I'll do all of my x's first. X to the 4th, x to the 3rd, and so on. Then my second term is a 2. So in parentheses are important because if this were negative, which it might be today, you need to be careful about raising negative numbers to powers. But it's just a positive. So here I put times 2 to the 6th. I'll just put a plus sign in front of that. All right. Behind the 6x, there's going to be a 2 to the what power? 5th. And then in this term, there's going to be a 2 to the 4th. Okay. So now we need to figure this out, and this is where sometimes people make pre-algebra mistakes. I'll see a lot of people on a test, and they'll type their calculator, and they'll go 15 times 2 squared. Like, they'll do 15 times 2, and then they'll square it. What mistake are they making? Yeah, they're not using the order of operations. You need to raise those to a power first, then multiply. So that doesn't matter here. It's x to the 6th. Okay. However, it does matter, not yet. It's just 2 times 6, right? So we have 12x to the 5th. Okay, now it matters. What should we do first? Square 2, which is 4. Then multiply by 15, which is 60x to the 4th. On to the next one. Now we are going to do 2 cubed, which is 8 times 20 is 160. All right, and now we're going to do 2 to the 4th. What is 2 to the 4th? 16 times 15. It's 240? No, 2 to the 4th times 15. It is, okay. Then we have 2 to the 5th times 6. So 2 to the 5th is 32. 32 times 6. Is it 192? Okay. Sorry, I started to write it because I thought it was, but... Alright, and then finally 2 to the 6th times 1. So there you go. Alright.